Hi, hello. So I just finished all the finals for this terrible semester. So I have some leisure time right now to record my progression in learning computer science. And I will introduce my final project for my CS225 data structure course at University of Illinois. So me and my teammates, Tina, Calvin, and Julian, did the whole project together. And the project goal is to use the OpenFlights dataset we downloaded from the website here, which is popular for interviews. And we want to use different algorithms to find the shortest path between two airports in the world, or we can find the shortest path among a starting airport, a transfer airport, and a destination airport. I will show you how this program works at the end. So OpenFlight provides us the routes. I think it's here, the routes, airlines, and airports information. We firstly need to find a way to grab all the useful information from the TXT file. So we wrote a simple function here called airport reader, which is very easy and simple C++ syntax. So we get the name, ID, and coordinates of each airport line. Airport, and we get the information line by line from the TXT file, like you can see here. And then we need to set up a graph, which enabling us to solve the shortest path problem. Here is the graph class in our program, which allow us to set up the vertices, edges, and weights on each edge. I can show you the different functions here. Get vertices, get edge, and set edge weight. Well, these are not important. Not so important in this project. And so like we firstly calculated the straight distance between two airports with existing airlines and set them as the weight of the edge. So we wrote a helper function get distance here. It's our helper function to calculate the shortest, the straight distance between two airports. And we can set them as the weight of our edges in the graph. Then let's talk about our chosen algorithms. We firstly implemented the DFS traversal. DFS. Yeah, so here is our main function, and this is our helper function for DFS. So DFS enables us to see how many airports how many airports are connected to the starting airport we want in the whole graph. The traversal gives us the airports we can go from the starting airport. So DFS will not give us the shortest path, and DFS is a very easy, a very easy algorithm. You can find the information online and studio codes online. Just remember to use the stack here. Very basic knowledge in data structure. To calculate the shortest path and solve the shortest path problem, we need to implement we choose to implement the Dijkstra algorithm here. This is our main function, and the Dijkstra path will back traverse the map we store here. So I will put a link of the detailed explanation from other video here. The main idea is we want to track the shortest path from the starting airport to the next airport. So we need to find a way to store our shortest pre-vertex and shortest distance between two vertices. For example, let me show you a simple diagram here. Like saying we want to go from A to B. So we have multiple ways to go from A to B, right? So we can go straight from A, B, or we can go from A to C to D to B, or we can go from A to C to E to D to F to B. So we have multiple ways to go from A to B, but the shortest way, the shortest path is straight to go from A and to B, right? So we store the pre-vertex of B is A, and the shortest path from A to B is 6. So we store both of the information in a map, in two maps, actually, in two maps. So we spent a lot of time on this Dijkstra function because we find some issues in the OpenFlights TXT file. Like you can see, yeah, you can see like for line 1655, it somehow jumped from 1699 to 1701. So I guess maybe some airports abandoned or eliminated from the dataset. So like sometimes we will met a segment fault for checking a non-valid index, but we finally fixed this issue. So the last function we implemented is the landpass algorithm, which is very easy. Like here, you just call the Dijkstra function twice from the starting airport to the transfer airport and from transfer airport to the destination airport. And here are our test cases. So the main issue for our program is that the running time is too long. It takes about 1 minute to run the program. So we created a very simple IO in the main function, which enables us to see the result of the program in the result.txt file. So I will show you how this works. We simply run the program by typing /final project. And it asks us to firstly type our starting airport ID. So like, for example, today, we want to go from Shanghai, China. Shanghai is here. Like saying we want to go from Shanghai to Tokyo. So the airport ID in Shanghai, I already searched is Hongqiang. The Hongqiang is not an international airport. Okay, so Pudong is a good one. 3406. We just simply type 3406 and it will run the DFS traversal. Let me show you the result. Yeah, you can see like these are all the airports we can go from the starting airport, which is in Shanghai, Pudong, 3406. Then we go to the second part of our program, like saying if we want to go to a destination airport in Tokyo. So we want to go to Tokyo for shopping. Let me search Tokyo. Okay. So the airport ID for Tokyo is 2279. Right. We're just typing 2279. It took some time to run the program. Oh, okay, it's finished running. Let me see the result. Oh yeah, just 2 airports. Because you can see like it's a very short distance, and I think Narita International Airport is also a very big airport. So there is a straight airline between Shanghai and Tokyo. Where's Tokyo? Oh, Tokyo is here, yeah. So there is a straight airline between Tokyo and Shanghai. So that's the reason why when we call the second part of our program, which calls the Dijkstra algorithm, it returns us a very short path, like just go from Shanghai to Tokyo. For this third part, we will choose a transfer airport. So for this part, let us show some cruel test case, like saying if we want to choose to go to New York first. So we want to go from Shanghai to New York. Where's New York? So New York is here, right? It's a long distance, like a triangle. We want to go from Shanghai to New York first and then go to Tokyo. So it's like a triangle. Let me search the airport ID for New York. Like saying we want to go to okay, LaGuardia. I've been to New York once. I like that city. So the airport ID is 3697. Simply type 3697. It took some time to run the program, sorry. Okay, it finished running. Let us check the results. Oh yeah, okay. So it gave us results. Let us see the map and to test if it's right. So we go. So our starting airport is in Shanghai 3460, and the next one is so the program tells the our next airport should be 4000, and let's search which airport is that. Okay. So it's in Iran. Okay, it's in Middle East. So we don't want to fly through the Pacific Ocean. We want to go another way, another side of the Earth. we want to go west. So Iran is here. Iran is here in Middle East. Yeah, it's possible. So let's just check the next airport, which is 3989. Whoa, 3989. Where's 3989? Okay, 3989. 3989 is in Iraq. So it's near Iran, right? Iraq, near Iran. Iran. Oh, okay. So it makes sense, right? It makes sense. We want to keep on going west until we go to the east coast of the North America. So the next airport we want to go is 1685. 1685. It's in Turkey. Wait, why we go to Turkey? So Turkey is still in between. Okay, so Turkey is in between Europe and Asia, West Asia. You can see we go from Shanghai to Iran and go to Iraq and go to Turkey. So I guess the next step would be in Europe, somewhere in Europe. Let me check to prove if I'm right. So the next airport is 1706. Turkey. Oh, so we're still in Turkey. So we like Turkey. We need to transfer in within Turkey again. Okay. Interesting. So let's go to the next airport, which is in, 3941. Wow, it's a long trip. Oh, finally we arrived at Europe, Greece. So we go from Shanghai to Iran to Iraq to Turkey, and then we go to Greece. And Greece is here in Europe. I think our next destination will be in West Europe. So let's check. 1, 1, 1, 2, 2, 9. In Madrid. Oh yeah, it makes sense. It's in Spain. What about the next one? So it's we are right now in West. We're right now in West Europe. And the next airport should be Boston. Oh, so before we go to LaGuardia in New York, we need to firstly go to Boston, an airport in Boston, which makes sense because they are all in the East Coast of America. Like Boston is somewhere, I believe, somewhere here. Wait, is it right? I think Boston is somewhere here. Philadelphia, somewhere, Washington D.C. Never mind. I think MIT. Oh, sorry, Massachusetts State somewhere here, and then we will go from Boston to New York LaGuardia Airport, which makes sense because I think LaGuardia don't have international airlines, so it only have the airlines within America. And then we will arrive at LaGuardia in New York, which is 3697. So if we want to travel from LaGuardia to Tokyo 2279, we need to go to 3448. Let's check which airport is that. Wait. Oh, so it's the same. So it's same in Boston. Oh, so our program tells us that if we want to go straight from New York to Narita Airport in Japan, we will go to Boston first, and then then we fly through the Pacific Ocean to Tokyo. So our shortest path would be Shanghai, Iran, Iraq, Turkey, Greece, Spain, and then Boston and New York. And after we arrive our transfer airport in New York, we will fly through the Pacific Ocean and go to Japan, Tokyo. So our program works, but I don't think in real life we will fly like this. It costs a lot. Okay, thank you.